Good morning. Today we'll discuss column and struts. Now the question is, what is a column and what is a struts? Why we will study this? What is its importance? Where we are using this column and strut? Now coming to this point, we can explain that column and struts are the compression members. So now the question is, what is compression member? Means the members which are taking compressive loads from the overheading structures are called the compression members. So column and struts both are the compression member. Now, then what is the difference between column and struts? Why we will call a member as column and why we will call it compression member as struts? Now, we can see in the next slide that the column are the vertical members. Those are taking all the compression, all the compressive loads. But the struts are the compression members but not the vertical members. These are the inclined or the horizontal members. Those are taking the loads, compressive loads. So this is the basic difference between columns and struts. Means columns are the vertical members and struts are the short columns or the compression members but not vertical. They are inclined or they are horizontal. Now you can see here in these two figures that there is a small bar taking the load of the beam. So this short member is called a strut. Here also the members are inclined and horizontal in nature. So all these short columns are called struts. Once again I am trying to clear you that struts are also columns, but struts are inclined and horizontal, whereas columns are only vertical. So here we can see columns are vertical. So now these are few pictures of vertical columns or long columns. These are the pillars or stanchions which are used as long vertical compression members. Now we will understand here what is a struts. You can see that this is a frame or a truss. These members are normally used in civil engineering structures or mechanical structures. In lots of heavy structures, truss members are required to take the heavy loads, heavy compressive loads. And in this truss, you can see that there are lots of small bars joined to one another to take the loads. So these inclined members are the struts. And here you can see that some are continuous struts and some are discontinuous struts. These long struts which are continuous in nature are called the continuous struts, and the short bars which are disconnected from each other and jointed with each other to make the truss, those are called the discontinuous truss. So now we can see here in this wooden net like structures, this is a wooden structures where you can find a number of struts, these inclined members making each angle, and this structures is complete a net of struts members. So these struts members are inclined in nature in these structures. Coming to the next part, classification of column. So columns are mainly categorized in three parts: short column, medium column and long column. So now what is short column? Why we will say a column is short or medium or long? See, when columns length is very much short as compared to its lateral dimensions, then it is called a short column. At that condition, what will happen? If we will apply some external load, then the column will be compressed and failed due to compressive stress only. That means If a column will fail due to compressive stress only, then that column is called a short column. Similarly, on the same ground, when it will be called as a long column. If imagine there is a long column, when we will apply some external load to a column, then what will happen? The column will try to buckle, try to bend or deflect from its original position, and due to that bending, the bending stress will develop inside the column before the development of the compressive stress. So in that case, column will fail due to bending only. In case of a long column, if we will apply some external load or compressive load, then compressive stress will not develop, and the bending stress will develop, and the failure will occur only due to bending stress. Only due to bending. Those type of column can be considered as a long column. Clear? So in case of short column, failure will occur due to compressive stress only, because there is no chance of bending as the column length is short. And in case of long column, the column will fail due to bending only. The bending stress will develop before the compressive stress will be developed inside the column. So in case of medium column, what will happen? In medium column, as it is neither will be considered as short or long column, so when we will apply some external load to the medium column, then the column will try to compress to some extent and also will be bent to some extent. That's why in such a column, the compressive stress as well as bending stress will occur. So the failure of the column will be occurred due to the combination of the direct stress or compressive stress and the bending stress. Now we'll discuss what is a buckling phenomenon and what is a buckling load. Just now we have discussed that when heavy load will be applied to a long column, then the column will try to buckle, bend or deflect from its original position. Okay. So when the column will start bending or buckle from its original position, then that phenomenon is called a buckling phenomenon. Means for a long column, the buckling will occur due to the development of bending stress before the compressive stress will be developed. So that phenomenon is called the buckling phenomenon. And what is a buckling load? If a failure will occur due to buckling, then the load at which that failure occurs or the load at which the buckling occur, that load is called the buckling load. Here we can see some shapes of the columns in various conditions. So in the first case, we can see that these are the shapes of the columns after buckling, or these are called deflected shape of the column. In case of a column fixed at both the end, you can see the first pictures, it is fixed at both the ends, and how the deflected shape is looks. So now we can see that at the end, as the support is fixed, or the column is fixed or restrained or rigidly tightly restrained with the support, so here bending of the column has not been occurred up to some distance, and after that the column has been bent, and the maximum bending has been occurred at the center, and then again we can refer to the other end which is also fixed, and at this fixed end the bending of the column is negligible, and after a certain distance from the end the column has been bent to some extent. So in case of a fixed end, the column bending will be of this type. The deflected shape will look like of this dotted or dashed line. So now coming to the second pictures also, we can discuss in the bottom end of the column there is a fixed support due to fixing or restraint nature of the column. Here the bending is quite negligible, and in case of hinged portion in the top part, the column is has been hinged or pinned. So in this case the bending has been fully occurred, and in the bottom part due to fixed support the bending is very negligible, and the shape of this kind of column will be like this. Similarly, we can see the various shapes of the column at different end condition. In this case, the fourth pictures we can refer that in this case the top and bottom both the ends are hinged, and in such a case as the ends are hinged the column has been fully deflected. So this is the shape. The dashed line is the deflected shape of the column in this condition. Coming to the next, here we can see some practical pictures of some column. Those have been bent due to heavy structures, heavy loads. Here you can see these structures has been bent. This is called buckling. This is called buckling. In this case also, all those photographs showing the bending or buckling of the columns due to heavy loads. Now, the scientist Euler's, he has explained the failure of long column due to buckling. So, as per his theory of failure, some assumptions has been made. So, what are those assumptions? So, those are the columns is initially perfectly straight and is axially loaded, and the column section is uniform, and the material must be perfectly elastic, homogeneous, isotropic, and most importantly the column section must obey Hooke's law. Okay. Now coming to the third assumptions, length of the column is very large as compared to the lateral dimensions, and the direct stress is very small compared with the bending stress. As we have just now discussed that in case of a very long column, when load will be applied, compression load will be applied to it, then column will start buckle first. It will start bending instead of compression. So he has made the assumptions that the direct stress is very small compared with the bending stress corresponding to the buckling condition. And the next assumptions he has made that the self weight of the column is negligible, because if the self weight will be considerable, then the column will not easily buckle. The column will not fail easily. So that's why we have to consider that the column weight is negligible, and all the joints of the columns are frictionless, because in case of friction, existence of friction, failure will not occur easily. That's why all the joints must be frictionless. That is his assumptions. Now there are some limitations also in Euler's formula. What are those? See, he has assumed that struts or columns are initially perfectly straight and the load is exactly axial. However, no columns, no no compression members can be perfectly straight, and load cannot be exactly axial because of initial curvature present inside the column. There is always some eccentricity. Similarly, what is the second limitations? The column will fail by buckling only. he has assumed that the column will fail by buckling only. But in practical cases, the column will not fail by buckling only. Before buckling, deflection will occur. The column suffers a deflection first before the buckling of the column. Now, we will discuss here the various end conditions of a column, because we will study the Euler's theory of long columns, where we will know the failure theory, why a column will fail. So before going to that part, we should know what are the various end conditions Euler has considered. And for each end conditions, we will derive one formula, using the formula using which we will be able to calculate the buckling load or crossing load. So what is buckling load? The load at which the columns will fail or buckle, that is called buckling load. So to derive the equation, the formula of buckling or crossing, we should know the 4 conditions he has assumed. What are those? Both ends of a column are hinged. Another condition is when the both end of a column will be fixed. Then one end will be fixed and the other end will be hinged. And one end will be fixed and the other end will be free. We can see here the pictures. Here we can see that in this condition, this is the type 1, both end of the column has been hinged. And in this condition, both end of the column is fixed. In such a condition, one end is fixed and the other is hinged. And in the fourth condition, one end is fixed and the other end is free. So for these 4 conditions, we have to derive 4 equations so that we can calculate the buckling or crossing load in the particular conditions. Coming to the next slide, equivalent or effective length of a column. What is it? What is the equivalent or effective length of a column? Because if we are considering a column, the original length is not its effective length. After giving a load to a long column, the column starts buckling, and after buckling, the effective length of the buckle portion, bent portion, is called the effective length of the column. If capital L is the actual length and LE is the equivalent length or effective length, we will explain now or study now what will be the effective length for the above 4 conditions we have discussed. These are the 4 end conditions and these are the L effective. I have also collected this photo from the Google. You can see here the L effective for the 4th conditions. As for Euler's theory of long column, what is the crippling load or buckling load? Already we have discussed that the load at which the columns will fail due to buckling or due to crossing, that is called buckling load or crippling load. It is denoted as PC. And as per the derivation, to calculate the PC or the crippling load, the formula is pi square EI by L effective square, where E is the modulus of elasticity, I is the moment of inertia of column section, and LE is the effective length of the column.